So today we will study the chapter 5. The topic of chapter 5 is the theorem. So from chapter 1 to chapter 4, we will discuss about what is electric circuit and what is voltage, what is current, and what is when and what's the meaning of the analysis of electric circuit. Then we will discuss about the law to govern the electric circuit. That is KCL and KVL. As I say before, the electric circuit can be analysis. These are the two law, the KCL and KVL. Based on these law, we can analysis. We can analyze all electric circuit. That's all. But to make but we want to make a kind of the general procedure to analysis the electric circuit. And if the electric circuit is complicated and complex, and there are many the voltage source and current source and dependent source and resistor, and later we will deal with a capacitor and inductor and the variable. That the element connection is varying using the switches. Then circuit is quite complicated. So we have some techniques to analysis how to solve the electric circuit. That was the node voltage equation, and another thing is mesh current equation. Based on these, the procedure, we can get the unknown variable to describe the electric circuit. And this chapter, we will study about some theorems. These are very similar with these two procedures: node voltage equation, node and mesh current equations. So to simplify the electric circuit, we will use these theorems. In chapter 5, we will deal with about source transformation. And that is about the change the voltage source to the current source, or the current source can be modified to the voltage source. So in some cases, the voltage source is preferred to analysis electric circuit, or the current source can be more easy to analysis the electric circuit. So in the case, we can transfer the voltage source and current source each other. Second thing is the Thevenin and Norton. This is about how to simplify the electric circuit. Actually, as you saw before, there are source here and resistor, inductor, capacitor, and whatever it is. There are many things out there. But actually, we want to know is some voltage occurs to some this resistor, especially resistor. And there are so many complicated systems in the current source, voltage dependent source, whatever it is. My concern is I only want to know the voltage here. We are here. In that case, because there are so many elements there, so to analyze all things is very complicated. So in this case, we can make this circuit very simple with one voltage source and one resistor, or one current source and one resistor here. You can make this complicated circuit with a simple thing like this way. Then we will adding the resistor here. So we call that this circuit is a Thevenin equivalent circuit, and this circuit is Norton equivalent circuit. This is a very powerful tool to simplify the problems to analysis electric circuit. And third thing is maximum power transfer. That means there are one source here and some circuit here, and we have the target resistor here. Our target is to transfer the maximum power to RL. Then what should we do in the viewpoint over here? Or we have some power transceiver. I want to get the maximum power from this source. Then how to make a receiver circuit? We'll deal about what should we do to get the maximum power transfer. The first, we will deal with about the source transformation. The source transformation means we want to change the voltage source to the current source. But in the case of the voltage source has a series resistor. In duality, the current source has the parallel resistor. So we can transfer the equivalent circuit from the voltage source and series resistor to the current source and parallel resistor. We call that is a source transformation. When you have the source transformation does not change the element current or voltage of any other element circuit. What's the meaning of the source transformation? I will give you some example here. If there are one source, voltage source here, and there are resistor and some resistor here, and resistor and current source and dependent source. I don't know what is that, but anyway, some here and here. Then because of that, there'll be current here, maybe some current flowing into the current, voltage, and current and voltage. I don't know what is exactly. If not this circuit, instead of this circuit, if there are one counter circuit and parallel connected resistor is connect the same way here and here, then this circuit can be replaced with this circuit, and this current and voltage and current does not change. That means in the viewpoint of this electric circuit, I don't care about the source. It could be a voltage source or it could be a current source. We don't care. Why? All element voltage and current is the same. Then you can say this source is equivalent to this source. That means you can change this voltage source and series resistor to the current source and parallel resistor. So between two circuits, you can transfer this circuit. We call that is the source transformation. The voltage source in series with resistor can be transferred to the current source with the parallel resistor. This is a way how to transfer the voltage source with the series resistor to the current source with the parallel resistor. Okay, if the source is same, that means this source and this source is equivalent. They're same. Then that means we connect the same resistor, the circuit. When you connect here, and here, then Vs and current. This is Vs and current IR. Vs and current IR is the same in the case of here and here. Then you can say that and that will be same because there is a source transformation. So how to make a if we have a voltage source with the series connected resistor, then we want to make the equivalent current source and parallel resistor. How can you make it? I will show you here. In this case, first we will analyze this in this second. This is oops, this is so long. This is not Vs. This is Vs. This is not Vs. This is V. This is a V. Then I want to calculate the V. What is the V? V is a divided voltage here and here. So V will be Rs plus R Vs. Vs is source voltage. And I want to define the current here. The current I. And I will be Rs plus R Vs. Then we can calculate the V other way. The V will be this is Vs. Define here because the current is I. So here is RSI. So V is Vs minus RSI. So that will be minus RSI plus Vs. Now how about this second? This second. We can calculate in the same usually, same procedure. So what is the V here? V is that is I. V is Ri. Then we need to check what is a what is a V? We need to check it. So if we define this is the V, this will be the V because we connect here. Then V is this can be written here. IP and LP and R, and this voltage is V. That means that circuit can be changed here. IP R is LP parallel R. So V is LP parallel R and I is IP. Why? This is a current source. IP. So that will be is LP plus R RPR IP. That is a V. What is I? I is because IP is divided to the RP and R. So there will be LP plus R LP IP. So we adding this. So VP, I will use that here. Then VP, I'm sorry, V is that V is LP IP minus I, there will be LP IP and LP I. That will be minus LPI plus LPIP. So we can compare the V here. V is that and V is that. So in the viewpoint of this case, I would like to do lead pens. V is minus RS I plus VS, and in this current case, in this case here, in this case, V is minus LPI plus LPIP. So in two cases, V is same and current is same. So to get this is the same equation, RS should be same with RP, and that value should be same with here. So VS should be LP IP. The same reason, IP should be VS divided RS. So there's a characteristic of source transformation. I'm going to summarize it here. If there's some current here and register here, then we will say this is VS and RS. Then we want to transfer the current source here. Then we divide this A and B. Then you can transfer the values in this kind of circuit. You get A, B. Then it says IP and RP. And then here, IP value to make a same two circuit. IP should be VS divided by RS. And RS value same with RP. I'm sorry. RP should be same with RS. Another way, if we have the current and parallel connected register circuit, then we make another same source with voltage source. Then you have to define the VS. Then VS will be LP and IP, and RS should be same with RP. We call that is a source transformation. Okay, I will do that with the example. The example 5-1. We have to determine the current, the IP and register RP here to make the source transformation. Okay. At first, we need to check what kind of circuit we have. This is a 12 volts, the voltage source, and series connected resistor is 6 kilo ohm, and the target circuit is 2 kilo ohm. But in another circuit, we have one current source and parallel connected R, and the same load resistor 2 kilo ohm. Then to make a same circuit, how to design the IP and RP? So there is a problem for the source transformation. Okay. Actually, we already know the solution. Why? I mean, this is a source and this is another source. So problem is to make a same performance, the same characteristic, how to define RP, how to design RP and IP and RP. So we already know. How should we do? IP should be you should know about that. VS divided by RS, and RP should be same in RS. So there will be 12, 6 kilo ohm. So the value is 0.002 ampere, and RP will be 6 kilo ohm. Then we need to check it. That will be 2 milliampere and 2 kilo ohm. Then we have to check. So the voltage VA and current I, VB and IB and VB. So that should be same and that should be same. We'll check it. The first 12, 6 kilo ohm and 2 kilo ohm, IA, VA. Then what is VA? A simple problem. Why? This is a kind of voltage divider. So there will be 6 kilo and 2 kilo and 2 kilo divided by 12. That will be 2, 12, 3 volts. So that 3 volts. Then what is IA? IA will be 2 kilo ohm and 3 volt is 1.25 milliampere. That's it. And this is another circuit. We need to check. If we design that current is 2 milliampere and make 2 kilo ohm. Oh, excuse me, this is not 2 kilo ohm. This is a 6 kilo ohm. I'm sorry. 6 kilo ohm. 6 kilo ohm. And the target is just 2 kilo ohm. It's VB and this current is IB. Okay. Then first we need to make out VB. What is a VB? There will be change is 2 milliampere and 1 resistor. This is a VB. What is that? That is a 6 kilo ohm and 2 kilo ohm is parallel connection. So that will be that means how much is it? Then or is that will be 8, 12 value 1.5 kilo ohm. So what is the VB? VB will be 0.002 ampere and so how much is it? 3 volt. So there will be 3 volts. So current IB is 3 divided by 2 kilo, so 1.5 milliampere. That will be 1.5 milliampere. So this result and this result is same. And I is 1.5, I is 1.5 same. That means the target circuit have the same voltage and same current. That means the voltage source and these current source is the same. And you can say this source can be transferred to the current source here, or this current source can be transferred to the voltage source in the case we want. Okay, this is another example. Actually, this is not 2, this is maybe 3. So we have to determine the R, the register R and current, and then using the source transformation. Okay. At first, the problem is we want to know about what is the relationship between R and current I. So to do that, we need to make the circuit. So at first, I liked to make this circuit here more simply. How can do that? I mean, you already know here. We say this is a VS, S means the series, and RS can be changed. IP and RP in this way. The IP means parallel. Then to make this circuit, what should we do? IP is designed in a way LP was same with RS. So in this case, we can make this circuit in this way, because if we define this is this way, this is VS, this is RS, then we can make a same circuit in this way here, and other remain circuit here. This is 2 milliampere R in this I. Then what is value of that? This is RP, excuse me. This is RP and this is IP. And then RP should do same with RS, and IP will be RS and VS. Here RS was 4 kilo ohm. Then that will be, what is VS? When define this VS here, then VS will be minus 12. And this is 4 kilo. So that means minus 3 milliampere. So we can say there will be minus 0.00 amps current source, and RP is 4 kilo ohm. Then in the point of these R and I here, the limits I can here, you just don't care whatever it is. So you point over here, I'm sorry, and the point of here, the other circuit can be draw simply. Then there will be one counter source. What is that? Minus 0.003, and one other counter source 0.002, and one parallel resistor is 4 kilo ohm. Then our target system, this is R and I here. Because this is a this is a counter source, then we can redraw. That will be minus 0.001, and this is 4 kilo ohm. This is R. That is here. Then we can redraw. Again, remain. This is I. Then what is the value of I? Then we can write the I that current divide to the register here and here. So that will be 4 kilo plus R M this is 4 kilo, and that current is minus 0.001. So that means 4,000 plus R and minus 4. That will be I. That is a result. So based on here, we can get the relationship between the R and I in this way. The next, we will study about the linearity. And what is a linearity? In chapter 1, we already discussed about the linearity and linear system. Now, in electric circuit, actually, it could be a linear system. If the system is not linear, then the analysis is very complicated, and we can deal with the electric circuit simply. Actually, fortunately, the electric circuit is a linear system, and in the case of the circuit, it consists of the current source and voltage source and R and L and C. And really, maybe next chapter we will discuss about the OP amp. The OP amp is kind of a linear component in the given condition. But anyway, in this book, in this electric circuit theory, we study the electric circuit as the assumption that the system is a linear. Now, what is a linear? I told you before, linear means the linearity that system satisfies the property of both the superposition and homogeneity. The superposition is in this way. Actually, if there are the magic box here. So if we adding the x, insert x, then the result will be the y. Then we test here. We insert here the x1. Then result was, I'm sorry, only here. When you insert here an x1, then the result was the y1. And when you insert this x2, whatever it is, the result was the y2. In the case we adding the x1 plus x2, then the result should be y1 plus y2. To satisfy this relationship, then you can say this system has a superposition. We call the superposition. In Korean, the 중첩. And another property is homogeneity. There's kind of the 비례성 in Korean. There's a thing here. We have the magic box here. When inserted, this is x1. that result was y1. Then we insert kx1. Then result is ky1. Then we can say this box satisfies the homogeneity. That is the homogeneity characteristic of here. So linear system will satisfy both the property here. This is very important and very good characteristic here. And what is your linear system? Linear circuit. The linear circuit is the circuit consists of resistor and dependent and independent source. Later, we will deal with the circuit, not only resistor but also the capacitor and inductor and so on. Then we can say that is the linear circuit. The resistor, capacitor, inductor, all of them is a linear element. And we can define the circuit input as a independent voltage and current source. So we define the input is a voltage or current source here. Then output is a voltage value or current value of any element on the circuit. Then you can say the linear circuit. We define that is the linear circuit. Then this is the way how to explain it here. If we have here in this way, then register here and register here. Then you say that is a V1, that is R1 and R2. Their value is VO. And if you define that is a input, and we define the voltage across the R2 is a V out. We define that is a output. The relationship between V1 and VO, V1 and VO is VO will be R1 plus R2, V1. This is VO. Then we say that is an input, and that will be output. So this is a linear circuit. What is the input and what is the output is depending on you. So we can define the output is not viewer. We can define the output is here. The current. Define the current. And then the relation between IO and V1 is IO will be V1 divided by R1 plus R2. It will be 1 R1 plus R2 V1. This is output and this is the input of system. So what is the input and what is output is depending on you, depending on the designer. So we can choose any voltage or current in the circuit as an input. You can choose any voltage and current of the element can be defined as the output of this circuit. Then, if some example here, the V out is a function of this here. That means, I will give you a simple example here. Another example I'll give you. There is the voltages here, and one resistor, and one resistor here, and we have a region here, resistor here, and we have another voltage source here. And then there's another example, another resistor here. We define the name over here is R1, and this is R2 and R3. And here I decide to choose, this is the value over here is VO, and this is V1, and this is V2. So VO is determined by V1 and V2. Then we can say, V1 and V2 will be input, and V out will be output. So we have to get the equation to get the V out with two inputs, V1 and V2. So that is the characteristic of this, the electric circuit. Then what should we do to get the VO? To get here, we will deal with about later, but anyway, you can do that here. It's not a little bit simple, it's not difficult, but anyway, you can choose, we can use node method here. So how many nodes here? 1 and 2 and 3. So I choose this node is a reference node. Then we define that VA. Actually, this is VO here. Then we define the current, that is I1, and that is I2, and this is I3. So what is I1? I1 is R1 divided by V1 minus VO. And what is I2? Is R2 divided by VO minus V2. And what is I3? I3 is I3 divided by VO is divided by I3. So based on this node, we can make a node equation. What is that? I like to choose the positive. In coming to the node is a positive sign, the sign. So I1 is coming to the node, so plus I1 minus I2 minus I3 will be 0. Then we insert the value here. So what's I1? R1 V1 minus V0 and minus I2. R2 V0 minus V2 minus I3. I3 V0 will be 0. Then R1 over R1 V1 minus 1 over R1 V0 minus 1 over R2 V0 plus 1 over R2 V2 minus 1 over R3 V0 will be 0. Then this is V1, this is V2, R1 V1 plus R2 1 V2 will be same with so there will be R1 R2 R3 R1 R2 R2 R3 R3 R1 V0. Based on this equation, we get the V0 will be R1 R2 R2 R3 R3 R1 R2 R3 V1 plus R1 R2 R2 R3 R3 R1 R1 R3 V2. So So based on this electric circuit, we define the V1 and V2 is input and V out is output. Then V out can be expressed of the V1 and V2. So we can say V out is a kind of whatever it is, we call this is A1 V1 plus this is A2 V2 in this way. So in the linear system, the general output voltage is expressed with the input, the voltage values. So V out is output and V1 and Vn is inputs. Then you can say A1, A2, and An, that values we call that as a gain. So in the linear circuit, the value of output can be expressed of the input values. So that is an example of that. There is a general form to describe the output of the electric circuit in the function of the input values. Then in the linear circuit, we can express the V out, output value, with the function of input values in this way. Then, because the electric circuit is linear, the superposition should be satisfied. What's the meaning of that? The meaning of that is the output of a linear circuit due to the several input is equal to the sum of the output due to each input working separately. That means if the VO1 is there are only V1 exists, not other input value is 0, then the result will be here. And this is a typo. This is 2 here. If there are no, the second input is not 0 and the other input is 0, then that result will be VO2. And if input 1 and 2 is not 0 and the other input is 0, that means VO is the same with the sum of two values. Then you can say there is superposition satisfied here. And homogeneity means if we add in here the V1, the value is VO. Then if we add in the V1 is multiplied by K, then VO will be multiplied by K. That is the homogeneity. So I'll give you one example, a simple example here. Express the VO, this is VO, and the input values of V1 and V2 and V3. The three inputs and one output here. So I'll give you one solution one. Then we can define that is a node A. So we do define this node as VA because there is a reference that there is a node voltage here. Then what is the VA? The VA, we point over here. We can make you can use the node analysis here. So at first what should we do? We define the current here. This is I1. Okay, I'll use this, not 4. Okay. I1, and we can also the current here is I3. Then what is I1? I1 will be V1 minus VA. And what is I3? I3 will be here VO. And what is a VO? Because this is a kind of a supernode here. So VA is the same with this is VO and V3. VO plus V3. So we make here, then what's that? I1 plus I2 plus I3 should be 0. What is I1? I1 here. 4E V1 minus VA plus I2 is I2. And I3 is 10 VO. That will be 0. Then we insert that value here. So 4E V1 minus VO minus V3 and plus 2 and 10 VO will be 0. So oh, it's long, I'm sorry. This is not plus, this is minus, because I3 is addition here. So there is minus, and there is minus here. So we simplify here. 1 divided by 40, V1 minus, VO minus, V3 plus I2 minus V0 will be 0. From here, 45 V0 will be V1 plus I2 minus V3. Based on here, 8 VO will be 1/5 of V1 plus 8 I2 minus 1/5 V3. So this is the result. I mean, we defined the V out is by inputs V1 and I2 and V3. In this way, we can get the result here. We can solve this problem in that way, and using the retry in another way. At first, I think they can be make more simple. How can you do that? I mean, we will use the superposition here because we already know about that. That solution, second solution is second solution is more important because we will deal with about the superposition. We will use superposition. When there are 3 inputs here, the V1, I2, and V3. So the point out here, we can make a 3 circuit. First, circuit 1, there are only V1. So the second row in here, this is the V1 and 40. What's the meaning of the current? Is 0. I2 is, in this case, I2 is 0 and V3 is 0. Right? What's the meaning of I2 is 0? That means there are no current, so that means it's a open circuit. And this is 0, that means this is a short circuit. So it can be written here in this way. So from here, VO1 is 40, 10, 40, V1 is 5 V1. Second is only I2. That means V1 is 0 and V3 is 0. Then what's the meaning of the here? V1 is 0. That means it's a short circuit. So there are only 40 ohm. And this is exist. So current source I2. And this is 0. So that means short. Short. And 10. This is 10. And here, this is V out 2. So that can be redrawn here. I2, 40, 10. This is a VO2. That means R is 1/40, 1/4 inverse, and I is I2. So that is what is it? This is that's it. So 8I2. That is a VO2 is 8I2. And third, there are only V3. That means V1 is 0 and I2 is 0. So V1 is 0. What's the meaning of that? V1 is 0 means this is 0. So this is a short circuit. I2 is 0. That means no current. So there is no connection here. So we can redraw 40 and only V3 and 10. And you find that is a VO. So we can draw the second again. This is a V3 and plus and 40, and we met 10. 40, 10. We met here. That means this is minus plus VO. So VO is divided by the VC divided by the 40 and 10. So 40 plus 10, 10 V3. But the addition is opposite, so there will be minus. So there will be minus 1/5 V3. This is the VO3. So by the superpositions, the VO is VO1 plus VO2 plus VO3. V1 is 5V1, that is plus 8I2 and minus 1/5 V3. It's the same result as we see before. Even though the procedure is a little bit different, but the result is the same. In the case of this example, the first approach is more simple, but the second approach is a little bit complicated. But as the problem, there are the complicated the circuit, the second approach could be a more simple to solve the electric analysis. It depends on the problem in the electric circuits.